Well, if you're looking for investors to help get this started and someone said, well, I'm interested in the technology, how much would it cost me to create one of these farms? What would you tell them?
Well, it totally depends on where we are. So there's a lot of logistics issues.
Well,
right?
let's say San Francisco Bay.
Well, we did an estimate for San Francisco.
Since we're already here and there's a ton of venture capitalists in this area anyway.
We did, okay, well, San Francisco Bay has its unique problems of getting permission to be able to work in San Francisco Bay. But when we did the techno-economic analysis, we were talking about a few $1 million to build a 1-acre system. That would be the capital costs. And then additionally, we'd need some operating costs. But think about what we're doing. We're potentially making a huge amount of biofuel. We're treating and cleaning the wastewater. We're providing habitat in the ocean, or at least in the bay. And we're looking at a sustainable system, a system that can be replicated all over the world to produce local sources of liquid fuel.
Well, everybody wants to be green these days, so you'd think that this type of thing would arouse a lot of interest.
It is definitely arousing a lot of interest. I've spoken on TED Global about this technology 2 years ago, and over 500,000 people have watched my TED Talk. In fact, your viewers can see my TED Talk. I think we can put up a link to it.
I think we have a slide somewhere that shows how to search for that.
Yes, good. Yeah, there's a big interest around the world in the Omega system, and I'm hoping that the system will catch on.
Now, who's developing the technology? Is it just you, or do you have a team of people who are working on it?
There was a team funded by NASA and the California Energy Commission that worked for 3 years to look into all of these technical details, and 2 students have doing their PhD thesis. One is finished with his PhD from Merced, and the other is finishing her thesis on the techno-economics of the Omega system. But now there is no funding for the project, and a global initiative is unfunded as well, but it's a group of volunteers, mostly students from UC Santa Cruz, who are looking into places around the world using Google Maps and data on the internet. And then we're trying to find people, once we have really good sites, people that are local people that work on wastewater or do aquaculture or interested in biofuels. And there's places all over the world that are expressing interest. India, all around ASEAN, China, Singapore.
I think people are looking for relatively low-cost solutions to environmental problems, and this sounds like it can solve a lot of environmental problems at once. Now, you're talking about taking the fresh water that's generated by the algae and growing food underwater. What kind of food do you grow underwater?
No, wait. So the fresh water that's coursing through those tubes that's wastewater that the algae are growing in is a completely separate environment from the marine environment underneath, where we're growing typical aquaculture species like scallops or mussels. We can grow abalone. You can grow fish. Marine species that are just taking advantage of the fact that we're building an infrastructure offshore. So we imagine this big marina that allows you to access an offshore environment. And now you build cages or containers, or you hang ropes or strings or something that allows you to grow shellfish. And the aquaculture industry is well established around the world. You can grow shrimps and such things.
I understand that some of the initial motivation for this was to provide recyclable materials for long space flights. In fact, we have a few slides illustrating that. Can we see the first slide in that series, please?
And so this slide is the space station, which is an interesting image in the sense that if you think about what it means to go out into space, the people living in space, in the space station, are totally reliant on solar energy. Obviously, there's not an extension cord that reaches up there. And the reality is that if somebody in the space station went outside without their space gear on, their life expectancy is about 15 seconds. Their blood would boil, would be killed by radiation damage. And so the reality of being in space forces NASA to think through how to use resources very efficiently. The wastewater recovery system that's shown here is a modification of what was developed for the space station to recycle urine as drinkable, usable water. And that's what we're doing with wastewater for the Omega system.
Okay, and I think we have another slide in this series. Can we see the next slide, please?
And so this is a concept of what it would be like if we were to try to imagine
This looks
people
like
living on Mars.
the red planet. That must be Mars.
That's Mars. And so what would we do on Mars? Well, there's very little water available on Mars, and there's not an atmosphere to breathe, and there's no plants growing on the surface of Mars. And so we envisioned living underground, growing plants to make oxygen, changing the atmosphere so that we can breathe and exist there. But this represents an example of a resource-limited environment, which is really the basis of how the Omega project started. I think it's the next slide.
Yeah, we have one more slide in the series.
And this slide shows the kind of cycle where you envision what we would consider a waste product here on Earth, something that's recycled as food, water, or energy. Because waste products on Mars are more valuable than what we have, anything available in the environment. So what we consider something to throw away in space and on Mars are things that we absolutely have to reuse. And that's the fundamental idea behind Omega. The notion of building an ecology of technologies where the waste product from one part of the system becomes a resource for another part of the system. That ecology of technologies is what NASA's been working on in what they call life support systems. And that was the seed that really sprouted into the Omega project.
We just have about a minute left. Do you think that this is going to catch on? Do you think that people will say, wow, this looks great, let's put some money in it and get it going? Are you optimistic?
I am. I'm really optimistic because we need to make a change. And all indicators are suggesting that the next generation is on one of the most important thresholds in the history of humanity, the transition from hunting and gathering our energy to cultivating energy and using resources on our planet in a totally efficient way.
Well, I'd like to wish you the best of luck for that. We've got to wrap because we are out of time. I've been speaking with Jonathan Trent, founder and director of the Omega Global Initiative. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman. We'll see you next time.